So lesson 4 is, lesson 4 and 5 are kind of combined. So we're involving this idea of factoring our trinomials, or if we say our quadratic formulas, right? Anything with an x squared is quadratic. And using this zero property of multiplication. So you'll be able to use factoring in the zero property of multiplication to solve quadratic expressions. Okay, your homework is from the packet. The do now is kind of like a review of what we've been factoring and doing. So if we look at number 1, you know, again, are you using a GCF, are you using difference of perfect squares, or are you using the AC method? So here, don't just do the AC method first because you have a trinomial. There's a 2 that you can pull out of each term first. And then once you get to, you have 2 times x squared plus 5x plus 6. Then you can say to yourself, all right, we can factor this, right? What 2 numbers make 6 and the same 2 that make 5? These are 3 and 2. So that is where this will now break into x plus 3 and x plus 2. And you would leave it like this. So that would be your whole answer for that one. And that's what we got there. All right, for number 2, there's no GCF. We have to do the AC method, which is what you learned yesterday. So 6 times negative 6 is a negative 36. You keep the 5. You're thinking what 2 numbers make a negative 36 that also add to positive 5. So again, you're listing out those factors and you have to make sure that they satisfy the negative and the positive, right? Because you did 6 times a negative 6 is negative 36. So those 2 numbers would be 9 and negative 4. You break up that linear term, right? 9x minus 4x is a 5x. So we're just breaking this one down, right? And then we group. So we split this up. What do they have in common? We can divide a 3 out of these terms, and we can divide an x out of these terms. So we divide, we get 3x on the outside. Okay, when you so this is a step that I'm seeing some of us, it's getting tricky. So if we go to here, so this is factoring by grouping. What can you divide out of both of these? So you can both divide a 3, can divide a 6. And they both have at least one x. So this is like your GCF for this side. So you pull out the 3x that you're taking out. And when you take out, what happens? So 6 divided by 3 is a 2. X squared, right, divided by just an x. Think about when you you're subtracting the exponents. So this just turns into x to the first. So you're left with 2x here. Plus, right, bring down this sign. We didn't take out a negative or anything, so it's still positive. 9 divided by 3 is 3. X divided by x cancels out. So then we're left with 2x plus 3. We want this on the other side, so just make sure. Now, look here. So we have a negative 4x minus 6. So we want to make sure we get a 2x plus 3. So, yes, they both have a 2 in common, but what's going to make this, so let's see, if I just pull out a 2, right? Negative 4 divided by 2 is a negative 2x. I don't want a negative 2x. I want a positive 2x. I want what's over here. So in order for it to get me a positive, I'm going to pull out a negative here instead. So this is going to be a negative 2 that we're taking out, because a negative divided by negative is going to be a positive 2x. Negative 6 divided by negative 2 is a plus 3. That's my laundry making all that noise, or my heater. So 2, they're the same. We pull that out, right? That's our GCF. And we have 3x minus 2 in the other one, right? Combine these 2 together to get 3x minus 2. Okay? So that was just to do now. So let's look at what we're learning today. So we've been just factoring with trinomials, quadratics, okay, doing just simplifying it, right? We haven't really been solving for anything. So now with this zero property, it's kind of giving you an introduction here. The idea of a zero property of multiplication is, right, multiplication is a product. So the zero property basically is when you multiply two things together, you're getting, when you multiply two things together, you're getting a product. But if you want something that equals 0 or a product of 0, one of those numbers has to be 0, right? If I'm going to multiply, two things to get me 0, one of these has to be 0. So that's what we're kind of dealing with here. We're applying this zero property of multiplication to solve quadratic equations, to get a value for x. What can x be to make it 0? So you'll see something where I'll just say solve the equation. Okay, they're telling you that x squared minus 25 equals 0. So you're kind of thinking to yourself, all right, well, and some of you can do this in your head, right? What number squared minus 25 is going to get me 0? Some of you might already be thinking, well, if we're just taking away 25, we have to do 25 minus 25. So that x squared value is technically 25, right? We're saying like, this is 25 minus 25 equals 0. So in some cases in your head, it's kind of easy, but factoring it is going to get you to be more successful. Okay, so doing this, we have, so for number 1 it says, and you can see the work here, but I kind of want to just explain it. So x squared minus 25 equals 0. You guys should know that this is a difference of perfect squares. Okay, so we can split this up and factor it as x minus 5, x plus 5 equals 0. So now we're solving it, right? So when we solve this, we are allowed to take each part and equal it to 0, right? Because we want to know what could x be. And in this case, right, either one could be 0, right? When you multiply two things together, both don't have to be 0, right? If we're multiplying, if we want a product of 0, I can have 0 times 0, I can have 1 times 0, I can have 0 times 1, I could have 10,000 times 0, I can have negative 5 times 0. These all equal 0 no matter what, right? So we don't know which one of these values, like we can, there's technically two values that could get me 0, right? And if I look back up here, right, 5 squared is 25, right? So 25 minus 25 equals 0, but what else squared gives me 25? A negative 5. So this is what it's showing you here. If we split these two up and we solve for 0 here, x, we add 5 to both sides, x equals 5. What do we do here to solve for it? X equals, subtract 5. So we have two solutions here, basically. We have x equals 5 and x equals negative 5. And if we check it, right, we go back to our original. And I kind of want to see this from you guys. If I use x equals 5 and I check, right, so 5 squared minus 25 equals 0, right, this does work. Or, right, if I use the negative 5, this also would work. So either one is a solution. So you should be having two solutions every time you do this. Okay? So let's try, let's look at the other one. So we factored it out, right? What two numbers make 10? Multiply 10 and add to 7, 2 and 5. So again, we factor it out. We're doing the same process we've been doing. We're just setting it equal to 0. We're solving for x. What could x be to make it 0? Well, there's two solutions. X could be, when we split this up, right? We're still splitting it up like we've been doing. X plus 5 equals 0. Subtract 5 on both sides, right? Get x by itself. X could be negative 5, which satisfies the equation, or x equals negative 2. So the solutions we're getting there's two different ones. And again, this is just the notation of the x values. So if we were to plug this in, negative 5 in, on this left side, we'll get it equal to 0. And if we plugged in negative 2, it will also give us 0. Okay, so there's not just one x value. All right, here's some done for you. Let's do one that we haven't done. So these two, okay, factor out, right? There's a GCF. This one's a GCF. Pull out an X, and then you can't factor anymore. So you just set this equal to 0 and this equal to 0. Add the 1 over, divide by 2, and here are your two solutions. This one, there's no GCF. So this is where you have to multiply the 6 and the negative 20. Let's do this one together because I know some of us wanted help on this new AC method. So let's do number 4. Okay. So number 4 is 6x squared plus 7x minus 20 equals 0. All right, so I'm going to do this one for you even though it's down on the paper. So again, you're thinking, do I have a GCF? Is this a difference of perfect squares, or is this the AC method with a trinomial? Okay. 6, 7, and negative 20 don't have anything in common. This isn't a difference of perfect squares, so I'm using the AC method. So this number is bigger than 1, so I got to multiply it over here. And I'm saying to myself, now I have, what are two numbers that multiply to negative 120, right? I multiplied those. And the same two numbers that add to 7. Okay, so this one might be a little hard to think about. Like, what are the factors of 120? We have 12 and 10. We have 4 and 30. Or 40 and 3. We have 15 and 8. So you really got to think about what makes 120. So this one might be hard, right? Because you have to add to 7. So these two numbers are going to help us here. Right? These don't add to 7, but these do. So we know 15 and 8 is going to be in here. Again, the way to help you is what two numbers make 120. Okay? To make this negative and make this positive, we're going to make the 8 the negative one, right? 15 plus negative 8 is a positive 7. Positive times a negative is a negative. So up here, right, remember, you break down this term. You're using these numbers. So you're breaking this into 15x and negative 8x. Some of you are forgetting this grouping method. Not many of you. Just make sure you show your work because I'm not seeing a lot of you showing it. All right. And then again, we're just going to break this up. Find a GCF. What goes into both? 3x, right? So we pull out a 3x. When I simplify this, this turns into 2x plus 15 divided by 3 is 5. X divided by x goes away. I want this here. So what do I have to pull out? I got to pull out a negative value. I know it's got to be a negative because if a negative divide by negative is going to get me a positive. Negative 4, they both have in common. So negative 8 divided by negative 4 is 2x. And then obviously that's what we want, plus 5. Okay, so now the whole thing is, remember these go together. So my GCF is 2x plus 5, 3x minus 4. But we're equaling it to 0 this time. This is our 0 property. One of these, we're solving it, right? Now we're solving for something because we have an equation or an equal sign. So we don't know which one is a value of 0, so we can do both. So we're going to break this up. 2x plus 5 equals 0, and 3x minus 4 equals 0. You don't need the parentheses. Sometimes I just do it by accident. So subtract 5 on both sides, divide by 2. Solve for x. X equals negative 5 halves. So that's one solution. And it'd be smart to check it. Add the 4 to both sides. Divide by 3. X equals 4/3. So here's one solution. Here's another solution. Okay? These are also called the zeros of the quadratic because we equaled it to 0. Okay, this work is on there. I just wanted to walk you guys through it. All right. So it's really what you're doing. You're using your factoring skills, but now you're just setting it equal to 0 to find those solutions, okay? And again, number 5 is a little different. It has a number over here. We don't want a number here. How do you get rid of that number? If it's a -5, you add it to this side, then you factor, okay? What two numbers make 24 but add to -11? And you still set that equal to 0. Okay? Same with this. We don't want this -7 here, so we're moving it over to the other side by adding it to the other side, and this is our new formula. Don't do AC method first, right? GCF. Take out the 7, and then do the AC method. Okay? I know this video was long, but I just wanted to walk through everything, and hopefully you guys are good with that.